Good day, grade 11. Yeah, welcome. We are going to focus on number patterns. That's the topic for today, which is dated 6 April 2020, Monday, which is today. This lesson is applicable to grade 11 as well as grade 12. Okay, since their syllabus includes the whole of number patterns, okay, plus the series. Now, let us look at the lesson objectives. What we are going to cover, we will look at the terminology, which are the words or terms that are used in this topic. You need to familiarize yourself with them because they will be used most frequently. And then we will look into different sequences that we have or patterns. And at the high school level, we focus on 3 sequences. The arithmetic sequence, the quadratic sequence, as well as the geometric sequence. All right. At grade 11, we are not really going to cover geometric sequence, although in grade 8 and 9 it is covered, but for grade 11 it is not part of the assessment or exam, so we'll only be dealing with arithmetic sequence as well as the quadratic sequence. Okay, and then let us start with our lesson, terminology. So what words or terms are going to be used most frequently? We'll be using the word pattern. Okay, you need to know what is a pattern. You need to know what a sequence is, a row, a term, nth term, or what we call a formula, as well as the language that comes from inequalities, which we covered in algebra in term 1. Okay, so grade 11, let us start. What is a pattern? Okay, now you may find that I have, let's say, numbers arranged in a row. For example, 2, 4, 6, 8, 10. What is it that we notice? Starting with the first number that we have, we keep on adding 2 to get the next number. Okay, and those numbers that we get, we call them terms. Okay, so when we get terms, those terms will form a row, or they will form what we call a sequence. Right? So because of we are observing that for us to get each of the terms in the sequence, we have to keep on adding a 2. Then that means we then are getting a pattern. Okay, a pattern is what we are observing. If I have, let's say, 2, 4, 8, 16, etc. What does it mean? It means from 2, I multiply by 2 to get 4, multiplied by 2 to get 8, multiplied by 2 to get 16, etc. So that is also another type of a pattern that we would be observing, and that will be a geometric. Don't worry about geometric, we'll be covering that in grade 12. Okay, so I've touched on a pattern. A pattern is a certain behavior that we observe with numbers, so we just call it a pattern. So in a pattern, especially where numbers are involved and they're displaying a certain characteristic, then we will get what we call a sequence. Okay, a sequence comes after numbers have arranged themselves in a row. Okay, another thing is each of the numbers that form a sequence will be called a term. Okay, so if I have 2, 4, 6, 8, 10, 2 will be the first term. Okay, the term in the first position. Then the 4 will be the second term, or the term in the second position. Then the 6 will be the third term, or the term in the third position, etc., etc. Okay, and then we have what we call an nth term. What's an nth term? All right, so remember, if I have 3, 5, 7, 9, 11, I know I keep on adding 2 to each one to get the next term. All right, but is there a rule or a formula that can easily give me all the terms of that sequence? Remember, I may ask you, what is the value of the 850th term? You cannot write all of them down and try to see what will be the value of the 850th term. Okay, but if I have a rule or I have a formula, okay, a rule or a formula underlined, then I'll be able to just substitute into the formula and get that big value. Okay, and in such a case, we need a formula or what we call an nth term. Please, the nth term, I'm not talking about the 9th term. I'm talking about the nth term. Are we together? Now, having said that, we also have what we call inequality language. What are these inequalities? Remember, in grade 11, term 1, we dealt with your solving for x. Then we got to a point where we spoken about inequalities, okay, where we looked at symbols like greater than or equals to, less than or equal to, greater than or less than. Okay, so these are terms that will be used in your number patterns. So it's more like integration of topics. Okay, we are taking what we learned in term 1 and we are putting it here in your number patterns. Okay, so you will need to convert words into mathematical representations. So you must be able, when they say which term of the sequence will be the first one to be greater than, maybe let's say 250. So it will be given in words greater than. But what is it that you need to do as a math learner? Then you need to take the word greater than, then write it in an inequality symbol. Okay, that is all about our terminology, and now we want to go to the next slide. Now, in the next slide, what is it that we have? I've written down some symbols for you, which you need to familiarize yourself with when we deal with number patterns. Okay, and I'm still using the example of 2, 4, 6, 8, 10, which is my sequence that I'm using as an example. So what will be 2? You said to me 2 will be the first term. And if it's the first term, symbolically, how do I represent the 2? I'll be saying T1 is equals to 2. T1 stands for first term. First term equals to 2. Hence, T1 will be the symbol that represents first term. Second term will be T2, and T2 will be equals to 4, using my example, right? Then, fifth term, that will be our T5. T5, of course, it will be equals to, let's check, 2, 4, 6, 8, 10. Therefore, our T5 will be equals to 10. All right? So these are just symbols that we use in number patterns whenever we want. Remember, mathematicians are lazy, and writing in words is something that to mathematicians is a difficult task. Okay, so we usually tend to use symbols rather than words. So please know T1, T2, T3, T4, etc. represent symbolical representation of the terms. Okay, and then what will be the last term of the sequence? The last one. Okay, so the last term of the sequence or the pattern will be Tn. Why n? Because you don't know what will be the last term. Okay, but Tn represents the nth term, the last term of the sequence. Okay, and as a result, we represent it symbolically as Tn. Okay, now that means in a sequence, if I have 2, 4, 6, 8, 10, and then your ellipsis, then you are given 500. What does it mean? Your 500 is your last term of the sequence, and it represents Tn. I hope I'm clear on that one. Please, I hope I'm very, very, very clear. Okay, now moving on. This is what I've already covered. Greater than, less than, greater than or equal to, less than or equal to. These are your inequality languages that you need to remember when we deal with number patterns. Okay. Now the next thing is the second part of the lesson, sequences. Okay. We said we are only going to look at 2 sequences. That is your arithmetic sequence and your quadratic sequence. and I'm starting with your arithmetic, or what we called a linear sequence in grade 8, 9, 10. This is very important. Okay, if I do not say linear sequence in your test, your exam, then I'll use the word arithmetic. But mostly of the time, we use arithmetic for grade 11 and grade 12. Then we use linear for grade 10, grade 8, 9, etc. Okay, so arithmetic sequence and linear sequence mean one and the same thing. So, obviously, if I'm going to look at two sequences, arithmetic sequence and quadratic sequence, you need to know how do you identify each sequence. Okay, how do you see an arithmetic sequence? One, it has the first difference being constant. What's the first difference? Okay, if I have 2, 4, 6, 8, 10, we notice that we keep on adding a constant number to each of the terms to get the next term. And that constant number that we keep on adding, we call it the first difference. Of course, somebody may say, why difference? Because difference involves subtraction. Okay, that is a nice question, a very good question. And how do we answer that one? So remember, if I am moving forward, I keep on adding, right? I will say 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is, that is when I'm moving forward. But we will ask you in the exam to write down or calculate the common difference. That's what we call it. We'll ask you to calculate the first difference or the common difference. How are you going to calculate it? Okay, if I have 2, 4, 6, 8, 10, I know the answer is 2, but how do you find 2? Okay, so that will be given by, that is my last point there, D representing what? The common difference, that first difference which is constant. So D will be equal to T2 minus T1, so it will always be what? The term in front minus the term behind, and we are talking about consecutive terms. Okay, so D, which is the first difference that is constant, or the common difference, is found by subtracting the term in front minus the term behind. Okay, but only for consecutive terms. That means I can say T2 minus T1. In my example, it will be 4 minus 2, and the answer is 2. Or you can also calculate D by saying T3 minus T2. In my example, it will be 6 minus 4, and the answer is 2. Or D can also be found by saying T4 minus T3. In my example, it will be 8 minus 6. Consecutive terms. Terms that are following each other. Okay, so that is how we find the common difference. So how do we see an arithmetic sequence or a linear sequence? One, we said it has a common difference. Okay, the number that we keep on adding to each of the terms to get the next term, or D being a constant. Okay, that is very, very important. The first difference is constant. Now, moving on, you need to know what things are applicable when you are dealing with arithmetic sequence. Okay, so your first term in arithmetic sequence, okay, is denoted as T1, but you also need to know, grade 11, that your T1 is also represented as A. Okay, this is just a fancy way of, engaging you with our maths, nothing more. Okay, don't be confused. A is also another symbol for the first term of an arithmetic sequence. Okay, so T1 and A will be equal because they both represent the same thing. Okay, good. Now, your arithmetic sequence may be finite or infinite. Let's talk about that. I remember in grade 10, we started talking about the word infinity, and we said that is when something does not have an ending. It continues up to a larger positive value or a very small negative value. Okay, so what do we mean when we say an arithmetic sequence is finite? It means we have the last term. We know what the last term is. And as a result, we also know how many terms are in that sequence. That is when it is finite. it stops somewhere. Okay, and then also we know when we talk about infinite, it means this sequence has a number of terms shown to us, but we don't know the last term. Also, we cannot tell how many terms are there in the sequence. That is when we deal with infinity or infinite series. Okay, so your arithmetic sequence may be finite or maybe infinite. In a case where it's finite, we can determine the number of terms in the sequence. Okay. Now let us look at the example number 1. I've given you 2, 5, 8, 11. Now I want you to tell me what is A. We said A is the first term, and there we go. Our first term is equals to 2, meaning A is equals to 2 or T1 equals to 2. What is 5, 8, and 11 representing? They represent T2, T3, and T4. How do we find our common difference? We said that will be T2 minus T1, or T3 minus T2, or T4 minus T3, or T5 minus T4, whatever, right? So when I look at my T2 minus T1, it is 5 minus 2, and I'm getting 3. Then T3 minus T2, 8 minus 5, I'm getting 3. Okay, so since the first difference is constant, that means this sequence is arithmetic. Is it finite or infinite? This sequence is infinite because we see ellipses there which are indicating to us that there are more terms following thereafter, and we don't know what the last term is. Okay, then I have another example there. 3, 7, 11. What is our first term? The value of A is 3, which is our T1, and then T2 is 7, T3 is 11. And as a result, how do we find our D? We're going to say T2 minus T1, that is 7 minus 3, we are getting 4, or T3 minus T2, where we are getting 11 minus 7, and that is 4. Now, the other thing I want to ask you is, do you see that after the 3 terms, 3, 7, 11, there are ellipses, then there is 35. Okay, what does it mean? It means on those dots, you see the dots there. Okay, these dots here, these dots here, they tell us that there are other numbers that are in place there, but they are not shown to us. But what we know is the last term of this sequence will be 35. Is this finite or infinite sequence? It is finite because we know where it is ending. It ends at 35. If we were to expand and check, then we would know how many terms are there in the sequence. By the way, 35 we said represents Tn. Okay, well done. Now, we've already spoken about that. T1 is the first term, T4 is the fourth term, Tn represents the last term, which is the nth term. Okay, and then n, very important. What does n represent? N represents the position of the term. Okay, when I write T3, okay, that means 3 is the third position. And as a result, when we look at this example, the first one, under example 1, what is our T3? It's 8. Meaning in the third position, the value of the term is 8. Okay, that comes from n. N represents the position of a term, but can also represent the total number of terms in a sequence. Okay, I've written both of those points, and you need to make sure you understand them. Okay, now next we are looking at the formula of the arithmetic sequence. How do you find the formula or the nth term of an arithmetic sequence? The formula is Tn equals to A plus n minus 1 times D. What is Tn? The last term or the nth term of the sequence. What is A? A is the first term. What is n? N is the position of a term, and D is our common difference, where we find it by subtracting the term in front minus the term behind. That will give us the common difference. Okay, This is the formula that we use for an arithmetic sequence. Now, let me give you a hint. How do you know what the question is asking you to find? If the question says which term, automatically they are asking you find n. Which term of the sequence will be equal to, they will give you a value, maybe 500, okay, or 250. So in a way they are saying the value of the term is 250, but we want to know which position will be giving us 250. Hence they say which term. So if maybe your n is equal to 17, that means T17 will be equal to 250. That is the 17th position will be equal to 250. Okay, which term they want you to find? N. And also they may say determine the number of terms of the sequence. Okay, number of terms of the sequence, I think I've already highlighted it there to say n represents, you see right there, n represents the number of terms in a sequence. Okay, very, very important. Now, I'm done with the arithmetic sequence. Okay, now we are looking at the last sequence, which is our quadratic sequence. You must be able to identify whether you are dealing with arithmetic or quadratic sequence. Not every time they will tell you to say this is arithmetic or linear or this is quadratic. Okay, you need to also be able to see that on your own. How do you see it? We will check now the differences. Okay, now with a quadratic sequence, I've written down an example. Let's check. 0, 3, 8, 15, 24 is the given sequence. Okay, we were not told that this is quadratic. Now, obviously, up to this point, a learner will be interested in finding the first difference. Okay, if it's constant, the learner will stop and say, this is an arithmetic sequence. Now, let's do that. 3 minus 0, we get 3. 8 minus 3, we get 5. 15 minus 8, we get 7. 24 minus 15, we get 9. But now there's a problem there because 3, 5, 7, 9 is not constant. Okay, we are not getting a constant number. So this cannot be arithmetic. No. It cannot. Okay, so what do? You say, well, let me just continue and do it again and see what happens. Then you say 5 minus 3, you get 2. 7 minus 5, you get 2. Then 9 minus 7, you get 2. Now, you notice that the second difference, listen to what I'm saying, the second difference is constant. Oh, okay. So a quadratic sequence has two differences. First difference and the second difference, but only the second difference is constant. Okay, and what else do we notice? The first difference forms a linear sequence on its own. Wow. Okay, that's good. Now, if the second difference is constant, then what is the symbol? We represent that by D2, and that is your second difference. So what's the difference quickly between an arithmetic sequence and a quadratic sequence? The difference is with your arithmetic or your linear sequence, you have the first difference being constant. Okay, immediately say this minus this minus this, then you are getting a constant number. Okay, but with your quadratic sequence, you are going to do this minus this minus that, but you notice that the first differences form an arithmetic sequence. They form a linear sequence. Okay, which means what? Which means go a step further and find the second difference. Then you notice that the second difference is constant. That is our quadratic sequence. Okay, that is how you see the two. Please, our 0 in this example represents T1. You are very right, very correct. Okay, but our 0 does not represent A. I'll repeat that. A in a quadratic sequence does not represent the first term. that is only applicable to arithmetic sequence and geometric sequence. A that we are going to see in quadratic sequence does not represent the value of the first term. Please note it down. When we are dealing with quadratic sequence, T1 is the first term. That's correct. But T1 in this case is the only symbol that we use for the first term. Okay. Now moving on. I have a small exercise here for you that I want you to look at. Let us say I give you 5 terms. A plus B plus C, first term. 4A plus 2B plus C, second term. 9A plus 3B plus C, third term. 16A plus 4B plus C, fourth term. Then the last term being 25A plus 5B plus C. Okay. And then I say to you, find the first difference. Okay, so 4A minus A is 3A, 2B minus B is B, C minus C is 0. So I've actually filled up the first difference row, and we notice what is it that we got next. Then let us now find our second difference. Is our second difference constant according to what we see here? Yes. Okay, it is constant. We are getting 2A, 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 2A. That means this will be our quadratic sequence. Well done. And therefore, what is the formula? The nth term of a quadratic sequence. I wrote it in purple there at the bottom here. Okay. The nth term of a quadratic sequence, or the formula of determining each of the terms of a sequence in a quadratic sequence is given by Tn equals to an squared plus bn plus c. Please note that down. Tn equals to an squared plus bn plus c. This is the nth term, or the formula for the quadratic sequence. Well done. Now, let us go to the next slide. From example 1, then, let us check what was example 1. This was our example 1. 0, 3, 8, 15, 24. First difference, second difference, constant. Then, how do we relate example 1 with this slide? Okay, we notice that 0 from example 1, okay, 0 from example 1 is at the same position as our A plus B plus C. And our 3, this 3 here, okay, is at the same position as our 3A plus B. Okay, and then lastly, our 2, the second difference, the 2 there is at the same position as our 2A. So it means 2A and 2 that side are equal. 2A plus B is equal to 3 that side. A plus B plus C equals to 0 that side. Yes? Yes, because they represent the same thing. Okay, now let's find our A, B, and C so that we can be able to find our nth term. Okay, for example number 1. So from example number 1, this is what I have. 2A is equal to 2 from the second difference in example 1. Okay, when I divide both sides by 2, there is my dividing. I'm dividing there. When I divide both sides by 2, I'm getting A is equal to 1. All right. And then we said 3A plus B is equal to what from example 1? 3. Therefore, where there is A, now I put 1 because A is equal to 1. 3 times 1 is 3. Now I've got 3 this side on the left, 3 on the right hand side, which is both positive 3. So the 3 and the 3 will cancel. B will be equals to 0. Okay. So far I have A, I have B. Now I'm short of C. How do I find C? We said A plus B plus C is equal to what from example 1? 0. Okay. We know what is A. 1 plus B is 0 plus C equals to 0 from the example number 1. Then finding C, our C then became a -1. So the formula, we said the formula for the quadratic sequence is Tn equals to an squared plus bn plus c. Then we substitute. Remember, a is 1, so usually we don't show 1. You remember, 1n squared is just n squared. Plus, what is b? b is 0. What is 0 times n? 0. So bn is gone. Okay. Then plus c. What is our c? It's a -1. Okay. Therefore, the full formula will then be Tn equals to n squared minus 1. Okay. Now, after that, I added a question again that says, determine the nth term for the first differences. Underline. We are determining what? The nth term for the first differences of the sequence. What is that I'm finding? I'm finding the formula for what? Let us go back. I'm finding the formula for these here, the first differences. I'm finding a formula for the first differences. Okay. Remember, I said to you, the first difference will form the arithmetic sequence. It will form a linear pattern on its own. Okay. So that means we can be able to use our Tn equals to, let us see, equals to a plus n minus 1 times d. Right. So the first difference sequence is 3, 5, 7, 9, where a, remember now I can say a because I'm looking at the arithmetic sequence. Although the arithmetic sequence comes from the quadratic, the fact is we are looking at the arithmetic. So we can be able to call our 3a, or the first term. Okay, then what is our d? Our d will be found by saying t2 minus t1. You can also use t3 minus t2 or t4 minus t3. Okay, so I used t2 minus t1 and I said 5 minus 3 and my answer was 2. That's my common difference. So using the formula for the arithmetic, Tn equals to a plus n minus 1 times d. We said what is my a? The first term, and that is 3. Then plus n minus 1 times what is d? 2. When you multiply 2 inside the bracket, okay, you find the product there. You're getting 2n minus 2 plus 3. But what is 3 minus 2? It's a plus 1. So the final answer became Tn equals to 2n plus 1. Okay, well done. Now, let us go to exam type questions. Now we are going to exam type questions. We are going to what? The exam. Okay. The second term of a quadratic, underline, of a quadratic, please underline, of a quadratic sequence is equal to 1, the second term, T2. Okay. I think I've already written it down there in red, 1. Is equal to 1. The third term, which is the next one, is equal to minus 6. I wrote it down there in red. And the fifth term is equal to minus 14. So you just keep one position, then I wrote minus 14 in red. For the fact that they didn't give me the first term and the fourth term, I represent them in different variables. I said x is my first term, then let the fourth term be equals to y. Okay, you're allowed to do that because variables represent unknown values. Okay, now determine the second difference of the quadratic sequence. Now, quickly, what do we know? We know that the second difference, meaning the second step after finding the first difference, then will be constant because it is a quadratic sequence. Now, when I find my first difference, I said 1 minus x, then minus 6 minus 1, minus 7. Y minus 6, y plus 6. And then minus 14 minus y, I got minus 14 minus y. And then, remember, for a quadratic, we don't stop there. We go a step further. Okay. Therefore, I still take the difference of the terms there in the second differences. So, minus 7 minus 1 plus x. Remember, if you are using brackets, then you'll have to distribute the negative, but I'm already doing that in my mind, okay? So minus 7 minus 1 minus 8, then minus x, it's a plus x. That's why I wrote x minus 8, okay? And then you can also do the rest, finding y plus 13 minus 20 minus 2y. But what do I know about x minus 8, y plus 13 minus 20 minus 2y? Second difference of a quadratic sequence is constant. Hence, I started by finding one of the variables. Remember, I cannot say x minus 8 equals to y plus 13. I'm just creating a lot of chaos, okay? But let me equate the same variable so that I can find the variable and then find the second difference. That's why I said y plus 13 equals to minus 20 minus 2y. I only have one variable to worry about, and that is y. Finding y, I found out my y is a negative 11. That is a grade 8 math. Finding y is minus 11. But remember, the question said find the second difference. So remember, y plus 13 minus 20 minus 2y, x minus 8, they represent the second difference. So you can take any of the two second differences that have y and just substitute y. Okay, so my D2, which is the second difference, was then equals to, I'm using the one with the 13, equals to minus 11, which is y, plus 13, and I'm getting D2 being equals to 2. That's my second difference. Okay, well done, and we have found our D2. Now B, hence determine the first term of the quadratic sequence. Let us go back. What is the first term? The first term is x. Meaning when I find x, I've already found my first term. What do I know? I know that my x minus 8 is the second difference, but the second difference I've already found it to be equals to 2. Okay, I'm not dividing. I'm just telling you that this part, the highlighted part, x minus 8, is equals to 2. So in a way, that means I can find my first term by saying x minus 8, the second difference, equals to the 2, which is the second difference. Finding x equals to 10, that is my T1, the value of the first term being 10, and I've answered the question. Well done. And then next up is another example. 2x, 12y are the first four terms of a quadratic sequence. Underline, quadratic sequence. Okay, this is a quadratic sequence. If the second difference is 6, you see, already we are given that the second difference is 6. Calculate the values of x and y. Okay, so I wrote down my quadratic sequence. After writing it down, I found the first difference. X minus 2, 12 minus x, y minus 12. Then I know that the differences of the first differences is equals to 6. I hope I'm making sense. So, second difference is 6. What does it mean? It means when I say 12 minus x minus x minus 2 in brackets, then that must give me 6. Okay. Okay, so now, when I equated that, I said this is equals to 6, then I solve for x. So minus x was minus 2x. 12 plus 2 was 14. Transposing 6 minus 14 gave me minus 8. And I got, dividing by minus 2, I got x is equals to 4. Then finding y, I just looked at one of these which has y. I said y minus 12 minus 12 minus x. You remember? So as a result, this is equals to 6, all of it, and I solved for y. Y was equals to 26. Well done. Next, question 3 from another past exam paper. The first 3 terms of an arithmetic sequence, underline arithmetic. Okay, this is very important. You underline because it will guide you as to what you need to do. Okay, the first 3 terms of an arithmetic sequence are 2p minus 3 is the first term. P plus 5, second term. 2p plus 7, third term. Okay. Determine the values of p. They last such questions. Where a sequence is given in variables, please think of how you find your differences. Okay. So T2 minus T1, if it's arithmetic, it will be constant. And therefore will be equal to T3 minus T2. Substituting, I found that my value for P was equals to 3. Okay, I can't teach you all of this. This is just math. But what is important is the value of p being equals to 3. Okay. Good. Well done. Next. The first 3 terms of an arithmetic sequence are, now they give us numerical values, -1, 2, and 5. Okay. Determine the nth term. What is the nth term? Tn. You remember, of the sequence. Okay. This is arithmetic. So my a is -1. How do I find d? I said t2 minus t1, which is 2 minus -1, and my d being 3. Then I have a and d. Can I be able to find the formula now? Yes. Remember, for arithmetic, the formula is Tn equals to a plus n minus 1 times d. Substituting all my stuff, I got Tn equals to 3n minus 4. Okay, well done. Now, 3.2. Calculate the 43rd term, okay, T43 of the sequence. So how do I find T43? Meaning where there is n now, I'm just putting 43. So it will be 3 times 43 minus 4. Let us write it down. There we go. T43 equals to 3 times 43 minus 4. And therefore my 43rd term was equals to 125. Well done. Next. Now, the sequence. Question 2. The sequence 3, 9, 17, 27 is a quadratic sequence. Okay. So as it is a quadratic sequence, we know we have the second difference being constant. Write down the next term. So what is it that they are looking for? They are looking for the term after 27. Okay. How do we find that? 3, 9, 17, 27. So the next term happened to be 39. How did I find that? I looked at my first difference, I looked at my second difference, and using that, it gave me 39. Okay. Now, 2.2. Determine an expression for the nth term of the sequence. What are we finding here? We are finding an expression for the nth term. We are finding the formula. How do we find it? We know that the second difference will be calculated using 2a. The first difference will be calculated using 3a plus b. Then the given sequence will be correlated with a plus b plus c. Okay. Then 2a is equal to, remember we take the first ones, equals to 2. And then we found that a was 1. Well done. Then 3a plus b equals to 6. And we found that our b was 3. And then a plus b plus c equals to 3. And then that is how we found our c being equals to -1. Remember, we have a, we have b, and c was equals to, the whole thing was equals to 3, and therefore c equals to -1. The general formula is tn equals to an squared plus bn plus c. Substituting, then I'm getting tn equals to n squared plus 3n minus 1. Well done. Now next. 2.3. Okay. Now 2.3, they're saying what is the value? Very important. Examinable. What is the value of the first term? We want that term to be the first one. That will be greater than 269. How do we do that? Now, underline greater than. You remember what I said? I said you need to take your words and convert them to math symbols. Okay, greater than, greater than. So that is your greater than. So which term? Remember, what gives you the terms? It is Tn. So we are looking for a term that will be the first one to be greater than 269, meaning Tn greater than 269. Okay, then let's look at how I've done it. Tn greater than 269. What is Tn? It is the expression for the terms. Okay, so n squared plus 3n minus 1. That's what we found for Tn greater than 269. In standard form, n squared plus 3n minus 270 greater than 0. Factorization. And then when you find your critical values, you find that n is equal to 15 or n equals to negative 18. Very important. N cannot be negative. cannot be decimals, cannot be fractions. We are talking about the number of terms. Okay, it's like if I ask you how many people are there, you can say there's 5 people, 11 people, or 20 people. Okay, can't say there's negative 5 people, or there is 3/2 people, or there is negative 0.4 people. Okay, so it must be a natural number. Okay, very, very important. Now, after finding that n equals to 15 or n equals to negative 18 is not applicable. It's out. Okay, it's not a solution. Okay, but we are left with n equals to 15. But when we substitute back n being 15 into the original standard form equation, you find that we are getting exactly 269. But we are looking for the term that will be the first one to give us an answer greater than 269. Okay, and that will be 16. N equals to 16. Remember, n equals to 15 is giving us exactly 269. But n equals to 16 is giving us something bigger than 269, greater than 269. Okay, that's why our answer is n equals to 16. Well done. Now next question, we have question 2. The sequence 6, 8, 10, 12, 164. Okay. Immediately I see ellipses, and then last number or last term. What does that tell me? This is a finite. You see, I've written it there. This is a finite sequence. Okay, and as a result, I can be able to find the number of terms. By the way, they are telling us that this sequence is an arithmetic sequence. Wow, good. Determine the nth term of the sequence. Remember, what's the nth term? The nth term is the formula. So you need to know what is A and what is D. How do you find A? A is the first term, which is 6. Then D will be T2 minus T1, which will be 8 minus 6, and we are getting 2. Then the formula is Tn equals to A plus n minus 1 times D, where A is 6 plus n minus 1 all times D, which is 2. 2 times n, 2n, 2 times minus 1 minus 2. Minus 2 plus 6 is a plus 4. Okay, well done. 2.1.2. How many terms are there in the sequence? Okay, meaning we need to find n. Remember, I said n also represents the total number of terms in a sequence. Okay, but do we know what is Tn? Yes, we do, and that is our 164. Do we know our A? Yes, 6. Do we know our D? Yes, 2. Therefore, we can be able to find the number of terms. How do we find it? Like that. Where there is Tn, I've put 164, all equals to 2n plus 4. Finding n, then there are 80 terms in the sequence. Okay, well done. Now the next question was, it is further given that the above sequence, okay, this sequence 6, 8, 10, 12, etc., forms the row of the first differences. Okay, for a quadratic sequence, Tn equals to an squared plus bn plus c, where the fifth term is 39. The values of a, b, and c must be determined. Determine the values of a, b, and c. Okay, meaning determine the ABC that forms the formula of a quadratic sequence. How did I do that? Very easy. Okay. First thing that we need to remember is our 3a plus b, where there is 3a plus b. Do you remember that they said this is an arithmetic sequence, which now forms the first differences of a quadratic sequence, meaning my 3a plus b will be 6, if you write it down. Okay, and my a can be determined by saying 2a equals to 2, because I still know what the difference is from 6, 8, 10, 12. Okay, now let us look into that one. Now, after saying that, I said 3a plus b equals to 6, and then where does the 5a plus b come from? Okay, being equal to 8, let us start here. Remember, my 8 represents the second term of the first differences. Okay, and when I come back here, What was the second term of the first differences? I hope you can see it there. The first term of the first differences was 5a plus b. So that's why I've equated it to that. Okay, so that means continuing, I said 5a plus b equals to 8. Then I said equation 1 and 2. Obviously, when I subtract, I eliminate a b. When I subtract the two equations, equation 2 minus equation 1, the 5a minus 3a, the answer is 2a. b minus b, 0, all equals to 8 minus 6 is 2. Then divide both sides by 2. You don't need to do this method. There are easier methods than this one, but this is also easy. Okay, then a is 1. After finding a, what did we say? We said 3a plus b equals to 6 in equation 1. Just substitute back your a, you got 3. Okay, but how do we then get c? We know that our c can be determined by saying a plus b plus c equals to something, but in this case it might be a very bit of a challenge because we don't know what the first term of the original sequence was. Okay, but what I've done, I've used the general form of the equation of the quadratic that they gave to me, which is Tn equals to an squared plus bn plus c. I substituted all that I know. Then I had Tn equals to n squared plus 3n plus c. But I know what is T5. Okay, so immediately I say T5, wherever there is n, I put 5. But T5 is 39, and therefore c was equals to minus 1. But I can also find the answers in this manner. 2a equals to 2. Where does the 2 come from? It was there. A common difference for the arithmetic, which now is the second difference for the quadratic, right? So a is 1, then b is still our 3, and then doing the same thing, T5 equals to, where does the 25a plus 5b plus c come from? This comes from the fifth term of what we did here. Okay, so this is T5, if you still remember. This is our T5. So T5 is equal to 25a plus 5b plus c. Hence, then we ended up getting our c being equal to minus 1. Okay, we have answered the question. They didn't say we must find the formula of the quadratic sequence. They just said find a, b, c. Okay, now this is the last question. I hope you have been understanding from the first problem, and now we are doing the last exam question. Okay, question 2. Given the quadratic number pattern, underline. This is a quadratic number pattern. Okay, that means we have the second difference being constant. So 3, 1, minus 3, minus 9. We find the first difference, minus 2, minus 4, minus 6, minus 8, minus 10. Not constant. We find the second difference, minus 2, minus 2, minus 2, minus 2. Now it's constant. Okay, write down the next two terms of the pattern, meaning write the terms that follow after minus 9. So using our first and the second difference, we found that the next two terms were minus 17 and minus 27. Well done. Now let us go to 2.1.2. Determine Tn, the nth term of the pattern. Okay, we are looking for the nth term of the pattern. Remember, 2a will be equal to the first one there. Okay, equals to minus 2. Therefore, a being equals to minus 1. Then 3a plus b will be equal to the first one there, which is minus 2, and we found our b to be equals to 1. Okay, don't forget to substitute your a there. And then a plus b plus c will be equal to what? The first one there. Okay, that is equals to 3. And then we found that equals to 3. Then you substituted your a and your b, and then our value of c was equals to 3. Okay, therefore the nth term will be given by Tn equals to, our a is minus 1, so we just write minus. Okay, but minus what? Minus n squared Then our b was a 1. We just say plus. There's a 1 there, but it's hidden. So plus 1n plus 3. Okay, well done. Now let us go to the next question. Which term of the pattern has a value of? Which term? What are we looking for? We are looking for n. Remember, I told you they will ask you in this manner. Okay, equals to which value? Negative 809. That is our Tn. This here will represent our Tn. Yes, this will represent our Tn. Okay, so using what we have obtained just now, which is the general nth term or the formula, we're gonna say minus. Let us look at it. We're gonna say Tn equals to minus 809. Then we substitute what is Tn, which was negative n squared plus n plus 3, all equals to minus 809. Standard form, very important. Okay, so what I've done, I transpose all the stuff on the left to the right, making them to be positive and negative. Signs will alternate. Okay, then for my standard form, n squared minus n minus 812 equals to 0, I factorized. My factors were n minus 29 and n plus 28. Equate each factor to 0, find n. N is equals to 29, n is equals to minus 28, and thank you for rejecting that one. Very important. Therefore, there is the final answer. The final answer is, it is T29, the 29th term, that will be equals to negative 809. Okay, good. Well done. Now let us go to 2.2. Given the arithmetic sequence, now underline, this is arithmetic. This is arithmetic. Okay, very important. This is arithmetic. Minus 1, 1, 3, 5. So first difference is constant, or the common difference. Okay. So they want you to find T53, the 53rd term of the sequence. Okay. There's many ways to do this one, but I've only decided to do 2. Okay. Now, the one that I've used was this one, to say, okay, I know the 2 represents, this represents my D. You agree with me? And then this here, this part here represents my A, the first term. So, on this slide, that's where I've used the formula. And then I found that my nth term was this one. Then I substituted T53, 53 everywhere where there is n. Okay. Then my T53 is 103. But on this slide here, I've said, remember, what is the first term? T1 is equal to A. You agree with me? T1 is equal to A. Then what is T2 equal to? T2 is equal to A plus D. You remember? And then that is when I say the first term plus the common difference. Then what will be my third term? My third term, which is T3, will be equal to A plus 2D. Notice, the D is always less by 1 compared to what you wrote here. Okay, so that is why I said T53 plus the first, equals to the first term plus 52D. Okay, therefore, I substituted A and D, and I got the same answer. Okay, very, very important. Well done. Now, let's summarize the lesson. What did we do? We looked at the terminology, very important for you to know, and then we looked at the sequences. We said only 2. Okay, there are 3, but grade 11 only 2 are important. Arithmetic sequence as well as quadratic sequence. Okay, that is your arithmetic and your quadratic. Then the nth term of the arithmetic is given there in green, and then we have what we call the first difference being constant, or the common difference, and it's represented by D. Okay. Also, under arithmetic sequences, your A and T1 mean one and the same thing. Okay. And how do we find D? We find D by saying T2 minus T1, or T3 minus T2. or T4 minus T3, etc., etc. With quadratic sequence, then we have what we call the second difference. Very important. Okay, second difference. And then the nth term of a quadratic sequence is given by Tn equals to an squared plus Bn plus C. Okay, this is very, very important. And I want to say to you, good luck and all the best. Get your level 7s and be successful. Sharp, sharp.